Okay, I'm going to try to give you an idea as to the key of this Doppler shift lecture tutorial. And the first question deals with these 6 dark line spectra up top. And one thing that's very important for you to understand in the directions here is that on the left side indicates these are your shorter wavelengths or your higher frequencies, essentially the blue end of the spectrum. Whereas as you move to the right on each of these little dark line spectrum, those indicate your longer wavelengths or your shorter frequencies. That's the red end of your spectrum. And so we see 6 stars and their dark line spectra, star A through star F. And we also see the corresponding temperature of each of these stars. So the first question asks us, do cold stars always appear to have a different number of lines in their absorption spectra than hot stars? And then we need to kind of back that up. And so what we can see is that, take your hottest star, for example, which is star A at 30,000 Kelvin. How many lines does it have? Well, it's got 1, 2, 3, 4. It's got 5 lines. And notice that we got 2 on the blue end and 2 on the red end and 1 kind of in the middle. And then we can look at some other stars and see if there's any particular trend or pattern. And so you can look at, let's say, E and F. Star E is a relatively cool star, in this group at least. It's got a temperature of 8,000 Kelvin. Compared to star F, which is the hottest one, the second hottest in the bunch, 24,000 Kelvin. Much, much different temperatures. And yet, notice that they both have 1, 2, 3, 4, 5, 6 lines. So star E, star F, both have 6 lines, but they have vastly different temperatures. And therefore, getting back to the question, do cold stars always appear to have different number of lines than hot stars? Well, certainly not, because star E and F both have the same number of lines, and yet they have vastly different temperatures. So we really can't draw any kind of conclusion about the number or about the temperature of a star just by looking at the number of lines in its dark line spectrum. Now, question number 2 says, do cold stars always appear to have more lines at either the blue or red ends of their absorption spectra compared to hot stars? And we need to cite evidence again to support this answer. Well, shucks. Let's take a look at stars B and F, for example. They are relatively close in temperature. B is at 20,000 Kelvin, F is at 24,000 Kelvin. But look at their absorption spectra. Vastly different. Star B has 4 absorption lines, with 3 of them being on the blue end of the spectrum, just 1 being on the red end, whereas F has 6 lines, and 4 of them are on the red end, and only 2 are on the blue end. So they're about the same temperature, but their line distribution is very, very different. So therefore, we can't just make this blanket statement that cold stars would have more lines at a particular end of the spectrum. Because we have an example of a star that has, or 2 stars that have essentially the same temperature, and yet vastly different distributions in their absorption lines. And then finally, in question 3, they ask, can you determine the approximate temperature for the star by comparing its absorption line spectrum to our examples? And it turns out, hopefully you learned from the first 2 questions, that the temperature of the star has nothing to do with the distribution of its absorption lines. And this is something we talked about in class. The only thing that the absorption lines tell you is the composition of the star. It gives you very little information about the temperature of the star. It just tells you the composition, because again, these lines are essentially a fingerprint of the elements that make up that star, at least the atmosphere of the star, the photosphere. And therefore, we can learn about the composition of the star, but we cannot learn anything about its temperature. The reason being, we don't know anything about the relative intensities of the different wavelengths that we're receiving here. All we know is that certain wavelengths are missing, but we don't know the relative intensity of each of these different colors of light that we are receiving. And we're going to get into that in the next page of this. So I'm going to stop post this first video, and then we'll kind of work our way through the rest of the key in the next video.